So welcome everyone to the third session on day 4. So this session is on simulation in IoT, and this session will be taken by Dr. Neha Karanjkar, who is an assistant professor in computer science and engineering at IIT Goa. So she received her MTech and PhD degrees from IIT Bombay in 2017, and then she spent some time as a postdoctoral fellow at the Robert Bosch Center for Cyber Physical Systems at the Indian Institute of Science between 2017 and 2018. Research interests are in modeling, simulation, and optimization of discrete event systems in the application areas of Internet of Things and computer architecture. So welcome Neha on behalf of everyone, and over to you to conduct your session.
Thanks for the introduction, Sharad. Am I audible?
Yes, you are.
Okay, and is the volume fine?
Yeah, it's fine.
Okay, so welcome everyone. And this session today is on simulation of IoT. Okay, so I hope that my screen is visible. Sharad?
Yeah, it is visible.
Okay, so let's start. So in this talk, I'm going to first describe the utility of simulation in IoT system. So where all does simulation play a role when you're designing or developing an IoT system? And a quick overview of the existing simulation tools. So what happens is if you Google for IoT simulator, you'll get a plethora of results, different types of simulators, and they are actually meant for different purposes, but they all have this, many of them have the generic name of IoT simulator. So I hope that after this session, it will be useful session for you in figuring out which simulator you should be using. Okay. Then we will just look at two specific applications. There are many use cases of a simulator when you're talking about IoT systems. So we'll look at two specific applications. One is when you want to simulate the endpoints, and the other is when you want to simulate and create digital twins. A quick overview, and let's see what are the requirements for a simulator in these two applications. So part of the hands-on session today, we will see how do you simulate the IoT endpoints. And for this hands-on session, we will be using Python and SimPy. So we will not be using any of the ready-made simulator tools, but rather we would be using a Python library called SimPy. And as clear from the theme of this workshop, the focus is on using free open source alternatives where available. So Python and SimPy, this combination is actually very powerful, very flexible. You can do fairly complex things using these. Okay. And this hands-on session will serve as a little motivation for learning further about SimPy. So I'll just give a brief introduction to SimPy. So what is SimPy? What is discrete event simulation? And what else can you do using SimPy? Okay. So let's get started. And if there are any questions, since I'm using my slide window, if there are any questions, I would request Sharad to voice them out to me. Okay. If there are any questions in the chat window, then I request somebody to voice them out. So let's start. So to have a picture at the back of our mind when we are discussing the applications, let's take this one example. So this is one representation of a typical IoT system architecture. There are many layer models, there are maybe 5-layer model, 4-layer model and all. So this is a typical 4-layer model. So this is applicable to smart city and other IoT systems. So let's take some example. Let's take an example where you have a smart parking system. Okay. So the device or the endpoint layer, so this is also called the endpoint layer, will consist of, let's say, your sensors to sense whether the parking spot is occupied or empty. And you have your different sort of sensors. You also have actuators. Let's say the actuator can start, open or close a gate, for example, to a parking unit. So the device layer or the endpoint layer consists of all the endpoints in your IoT system. Okay. And typically, some of these sensors or actuators are very small. They don't have any computing power. So you need to connect them to a gateway. So the gateway acts as a gate to connect these nodes to the network layer or to the internet. So typically a gateway could be a Raspberry Pi or some other small device. It could just be a Wi-Fi node also. So let's take this gateway to be something like a Raspberry Pi. Okay, and then we have the network layer. So these packets travel across the network, and typically we'll have a middleware layer. So the purpose of the middleware layer is to kind of aggregate all the data and to serve as an aggregator of all this data. So let's say all the data is collected on some cloud platform. So this could be actually a local server. It need not be on the cloud, but let's take for our example, this could be a cloud server. Let's say this is on the cloud, some cloud platform, which is collecting all the data, okay, and filtering out some things, processing that data and so on. And then you have user apps. For example, if you have an app installed on your mobile, that will query this middleware layer to tell you the next best parking spot in your vicinity. Or you may have a parking spot that you want to offer as an administrator. So your app will, allow you to send control signals to open or close some actuator also. So these apps can be different kinds of apps that have different permissions. Some may only allow you to read some sensor data, some may allow you to send commands also. Okay, so this is a typical model, and let's have this at the back of our mind when discussing about simulation. So where does simulation find utility in this 4-layer model? So first is during conceptualization, when you have nothing built at all, there is nothing built, and simulation can be used for creating demos, visualizations, and so on. So at different layers or different stages of your development, simulation plays a role. So right at the conceptualization stage, when you have nothing built, this simulations can be used to create visualization. So basically, you simulate all of the components, right? Okay, just simulate the user experience, for example. Okay, the second is during development. So this is a most important use for a beginner of simulation tools. That is when you start building some parts, you simulate the other parts to complete a picture. So let's take a particular example. So suppose you have one Raspberry Pi node and you don't have others, but you want to simulate hundreds of nodes. So you have actual one, a real one, and you simulate hundreds of them. Okay. And you connect them to a real middleware, which is actually collecting your data. So one is sending real data and the others are sending simulated data. Why would you need that? Because, well, it's sometimes expensive or infeasible to buy all the nodes before your system is built. Sometimes you may want to explore these different options before buying. Sometimes you may want to proceed with the development of all these layers in parallel. Okay, so you want to develop your cloud application, and in parallel you want to design your hardware nodes, for example. So you should be able to start design of your middleware layer before you have all the devices. So you simulate the devices. Okay? So that is about you simulating the device layer. Why would you need to simulate the network layer? So first, for example, the device layer simulation will consist of simulated nodes which generate some packets, some messages using your typical IoT protocols over the network. And you may also simulate devices which respond to commands from the other side, right? So what about the network layer? Why do you need to simulate the network layer? Where, let's say you are interested in modeling latency issues. For example, if you have a temperature sensor and if the temperature crosses a certain limit, then the cloud platform should send a command to turn off the heater. So the latency, the delay is very important in this. So you want to test if there is delay in the network, will your system work? So you want to simulate aspects that are there in the network layer. For example, latency, jitter. Jitter refers to like when different packets that you actually send in nice regular intervals, they arrive mixed up. They arrive with different periods between them. That's jitter. So if you want to simulate such things, you need to simulate what happens in the network layer. Okay. Then there is a middleware layer. So suppose now you have devices. Let's say you have some nodes, and you don't want to create your middleware from scratch. You can use existing cloud platforms, like let's say Thingsboard example that was shown in one of the previous sessions, right? So I would call that a simulator as such, but that's more like it builds a middleware or a cloud platform for you. But let's say you actually want to do something more complicated in your cloud platform. Then in the beginning, you will just simulate some simple functionality using AWS or Thingsboard or something like that. A simple dashboard. Okay, so in a sense, I'll not call this a simulator, but something to serve as a placeholder for this layer when you are working on the other layers. Okay, there are also middleware simulators or cloud platform simulators, so we'll see them. And finally, there is an application layer. So what should the application layer do? It should send requests to the middleware layer, get updates. So basically, you should model communication between this other layer, and you should be able to simulate how it looks and all that, right? So your typical application layer simulators could be when you develop these applications, mobile applications, Android development kit, for example, or something like that. So depending on what layer you're working on or what layer you're focusing on, you will need a different kind of a simulator. Okay. So during development, so this is a key idea for beginners. So when you are building some component, you simulate the other components that don't exist yet. Then an important utility is during testing. So an example is functional validation. Okay. So for example, we are designing a smart parking system. So these are all sensors and actuators. Okay. And we want to design our smart middleware. So let's say this middleware, if some sensor value is detected, it should send some control. Okay. So for example, let's say if the temperature rises above 100, then it should send a control to turn off the heater. So you want to test if it works under different scenarios. Okay, let's say you tested it for one node, but what happens if 100 nodes send this data simultaneously? Or if there is power failure and suddenly all the sensors in a particular locality are affected. Okay, suddenly there is a rush of messages from the device layer. So will your middleware work when such a thing happens? So you want to simulate such fault scenarios. And actually waiting for faults to occur is not a good idea. So it's a necessity to simulate worst case or fault scenarios. So that's a very important use of simulation, that is functional validation. Okay, you want to check all the functionality. So you have programmed in your middleware what should happen if you get a certain type of message. Okay, but you want to try out all those scenarios. So that is, simulation is the straightforward way to do it. Then there is performance testing. So does your cloud platform scale if you have millions of devices? Or is it only useful up to 10 devices? So you want to test scalability, you want to test performance. So for this, simulation plays a role because, well, it may be expensive to actually deploy millions of nodes. Okay. And finally, during operation. So a use case of IoT systems is something called digital twin. So I will define this later on, but you must have already heard this term. It's a very common term. It just means a model of the system, a simulation model of some real system which is continuously in sync with the system. So we will see this in little detail. So when the system is under operation, you might build a simulation model of the system just to do monitoring, prediction, and so on. So at different stages, simulation comes into picture. Okay. So here is a quick overview of some popular simulation tools. So many of them are called IoT simulators or IoT sim, for example, but they are different. They have different purpose. So this is just an overview, and the disclaimer is that I am not an expert in all of these. This is just like a overview of the available tools, and you may need to look them up in detail depending on your need. But I hope that this diagram will help you to quickly arrive at the tool that makes most sense for your purpose. Okay. So if you want to simulate the device layer, you want to simulate different devices. For example, let's say you have a middleware that you want to test. Then there are these tools. IoT5 is a commercial tool, AWS, IoT Device Simulator. So these are all commercial tools in this box. So network simulators, some of them are open academic simulators. So NS3 is an academic simulator. Then you have Cup for simulating wireless sensor networks. So let's say if you are developing a wireless sensor network, then where do you place the nodes? How do you optimize for energy and so on? So there's a simulator for doing that. And this is your standard network simulator. Okay. Then you have some simulators for the cloud layer, Cloud Sim, IoT Sim, then again IoT file database simulator and so on. And finally, for the app development, you have Android or iOS simulators, like when you want to develop an application, okay, or you just want to check if the data is available. So let's say you model this device, it's sending the data, it's being stored, but you want to check whether that data is available with the correct topic. Say, for example, in the previous sessions, you learned about MQTT protocol. So data is published with some topic. So you may want to create a dummy MQTT client which subscribes to that topic and prints the message. So you might say, is that a simulator? Well, it is. It's simulating the behavior of a client. Okay. So at different layers, the purpose of simulation may be different. So I hope that this quick overview will help you to identify the simulators that you may need to use. But in this session, we will be looking at an open source, just a bare Python library. We'll be just looking at Python for simulation. Okay. So let's take one example. So we saw many examples, right? So simulation of networks, cloud, and so on. So let's take the simulation of IoT endpoints as one particular example. Okay. So that means I want to test my cloud platform. And I may have some real nodes. I want to simulate the rest of them. So I want to generate traffic in real time, network traffic. I want to simulate these many devices. They may generate some traffic, let's say sensor values, okay? And this the cloud platform may send some control signals. Now I should be able to, if I'm simulating, I should be able to visualize or see the effect. So for example, if I have a temperature sensor and a fan, then if I simulate that the temperature exceeds the limit, I should be able to see that a command came to turn on the fan and the fan was actually turned on. So if I'm able to see that, it'll be very useful for checking, for demos and so on. Okay, so I should be able to see both the status and the state, the messages, the traffic being generated, and the effect of the control signals. Okay. Now let's look at this interesting thing here. There is a fault injector and a state injector. I mean, what is the purpose of this? So first of all, I should be able to simulate many things. Let's say many nodes. Okay. Sometimes there is some interaction between these nodes that I want to model. For example, let's say I have a street light. Okay, there's a road, and there are some smart street lights. And the functionality of the street lights is that if they have a ambient light sensor, if it is daytime, they are off. If it is nighttime, they turn on and they are continuously transmitting the information about the ambient light. Okay, and they also have a detector to check if a vehicle arrives. So in the night, they may be dimmed, but if there is an approaching vehicle, then that is detected. That signal is sent to the server, and then the cloud platform will send commands to the neighboring street lights to turn on. So when this particular thing senses that there is a vehicle coming, it turns on, and the next few street lights also turn on. So that will be a useful thing. So there is a sensor value going from this street light to the middleware, and then a command going to neighboring lights to turn them on. Okay. So I want some sort of interaction. Now there may be, this is through the middleware. There may be a case where there is a direct connection between the street lights. Okay, it's not going through the middleware, but some neighboring street lights are connected, so that if this light turns on, then the neighboring few lights will also turn on directly without sending a message. I may want to model such things. Or I may want to model multiple vehicles and show the effect or visualize the effect. Okay, so I want to model interactions between these endpoints. I also want to model interaction between them and the environment. Okay, for example, let's say I have some temperature sensors, okay, and some weather. Let's say I have some weather stations, and this is some geographical area. Then all the weather stations in this geographical area will have similar temperature and humidity values, and all the ones in this will have some other values, and so on. And there will be some gradual change across them. I want to model such things. So there is an environment which is being shared by all of these sensors, and that environment is kind of determining what should be the sensor readings of all these. So I want to model all such things also. Okay, and of course for modeling faults, for example, all of these sensors located at this, maybe they all have a common power supply. So when that power supply goes off, all of these nodes suddenly turn off. So what happens in such a scenario? I want to model that. So there could be a fault injector for injecting a fault in the simulator. So this is all a simulation environment. Okay. So why do I want to simulate IoT endpoints? So it is expensive or infeasible to deploy thousands of real endpoints. I may want to develop the middleware or app layers, and this development can be done in parallel with hardware deployment. Okay. I may want to simulate various scenarios like power outages, failures, and so on, and performance validation. So what do I need? The requirements. I would need to first of all model multiple devices sending and receiving messages. So these messages are real. So actual messages in some format. Okay. Then I may want to describe the node behavior with respect to time. Okay. And I may have multiple levels of abstraction or detail in mind. So at what level of detail do you want to describe your node? So let's say your node is a temperature sensing node. How do you describe its behavior? Okay. Let's say a very abstract model is that here is a temperature sensing node, and it generates a message after periodically with a given interval. Let's say after every second, after 1 second, it generates a message with attributes temperature and name and something like that. Okay, so it generates, that could be a very simple behavior. It just generates a particular message to the network with a given interval, and you may be specifying the format of this message. Or maybe it generates random sensor values. It just puts some random sensor values and generates periodic messages. A little more detailed model could be that you actually read the time series data from some file and send them as messages periodically, or with some intervals, not periodic, but some other intervals. A little more detailed model is you model the state device transitions. So for example, initially when the device is in the discovery mode, let's say you have a device which is in the initialization mode, initialization state, and after some time it sends a message to the cloud platform, it gets some initialization values, it enters into the operational state. In the operational state, it regularly sends some messages, sensor values. Every once in a while, it enters into the error state. Okay. If it is in the error state, then if the cloud platform sends some control signal, then it can enter the some intermediate state, and then from the intermediate state, it can enter the operational state, and so on. So you want to model all these state transitions. Okay. So you may want to do this in detail. So in different state, the device behaves differently. In operational state, it will send messages at, let's say, 1 second interval. In error state, it will just send one message or whatever. I mean, you may want to describe its behavior and different state transitions. Okay. Or you may want to model multiple devices interacting with each other and with the physical environment. So this is the example of the street light that I just described, where you may want to model devices actually sending messages or interacting with each other. So for example, there is a temperature sensor and a fan. If you turn on the fan, then immediately the value sensed by the temperature sensor should fall down, right? You want to model this. So finally, let's say the most detail that you want to model is actually model the entire gateway and the sensor node in detail. Let's say you want to use an emulator of a Raspberry Pi running some custom firmware. Okay, this is when you want to actually focus on developing your hardware. You may want to model your endpoints in much greater detail. Okay, so you should be able to decide what level of detail you want to model your nodes. Okay, some other requirements: your simulator should support different communication protocols, let's say HTTPS, MQTT, COAP. So we saw some of these protocols in the previous sessions, right? So you should be able to switch between these protocols. You should be able to model many nodes, like millions of devices if you want, and the simulation should work. Okay, and then we want the simulation to run on a cloud platform as well as on a single computer. Okay, and of course it should have logging, should provide a detailed log, it should provide reproducible results and so on. Okay. So these are some requirements that we have of IoT endpoint simulators. So coming back to overview, we will see two specific examples. One is simulation of the endpoints, and the second is of digital twins. So just listing down what are the requirements and so on before we move on to our hands-on session using Python. So are there any questions so far? Okay, so let's move on. So here are some commercial and academic tools for simulating the endpoints. Okay, so IoT 5 was, I think there was a free or a trial version some time ago, but now it's paid. Because if I saw recently, there is no trial version, so it's a paid software. Then you have AWS Device Simulator. Okay, so you have these commercial options, and there are some academic or free open tools, but some of them are for very specific applications. So for example, Kuja allows you to simulate endpoints that are running the Contiki operating system, and TOS-Sim is for nodes which are running the TinyOS operating system. Okay, then Node-RED is also a flexible endpoint simulation framework. And what we will discuss today is a very flexible option, a generic discrete event simulation platform. Okay, and we will see how this can be used for IoT specific simulations. So we will see what is a discrete event simulation, what is a discrete event simulation platform, and how you can use them for IoT simulation. So the next application that let me highlight is that of a digital twin. So what is a digital twin? I don't know if this was covered in one of the previous sessions. So suppose you have a machine. Let me just discuss this very briefly. So let's say you have a machine or a process or a system. Okay, let's say this is a chemical factory or a machine or an industrial process. Okay, and you have this IoT infrastructure for continuously monitoring this machine. So you have sensors, let's say temperature sensors, vibration sensor, pressure sensors, or so on. And these sensors are continuously collecting information about the machine. Okay, and that is being sent to a backend. This could be a cloud platform or a local machine, and it's being stored. Okay, now a digital twin is actually a simulation model of the real system. So let's say you use all this data and you build a simulation model. So this is a simulation model of this machine. which is actually continuously kept in sync with the real machine. So for example, if the real machine starts doing a job, it goes from idle state to busy state, then the simulation model should also reflect that. And it is possible because data is continuously being measured and used to keep the simulation model up to date with the real system. Okay, and then you may use it for dashboarding. Okay, and for the simulation model could be used for prediction. Let's say, for example, if whatever this machine is doing continues for the next 10 hours, will I be able to produce a certain number of output products in my assembly line, for example? So we can use it for short-term prediction, what if analysis, optimization, and so on. So there is a simulation model which is continuously kept in sync with the real system. And there are actually three terms which you may hear. So there is first is called a digital model. This just means a simulation model. So let's say if you have observed something about the real system and you measured all these parameters like how much time it takes on an average and so on, how much energy it consumes, and you plug in those parameters to build a simulation model, that's just called a simulation model. But if you have a continuous measurement of data, okay, then that is called a digital shadow. That is, there is a continuous measurement of the sensor values to keep the simulation model in sync with the real system. Then it's called a digital shadow. And digital twin is if there is one more component, that is, you are using this simulation model and controlling the real system in some aspect or the other. So for example, you continuously measure the data and the simulation model predicts what will happen in the next 5 seconds. And if the model predicts that the system will overheat, for example, then you will send a signal to turn off the system. So that's an example where this loop is complete, okay, and that's called a digital twin. So what are the uses of digital twin? If you have a digital model or digital shadow, you can use it for monitoring. So shadow can be used for monitoring. You just monitor what's the state. And further, you can use it for prediction, optimization, what if analysis, and so on. And a digital twin can also be used for control. So prediction and control. Prediction and continuous control. Okay. So what we saw is we saw two examples of where simulation plays a role. Okay. One is simulation of endpoints, and the other is digital twins. And the platform that we are going to see, Python, is useful for both of these applications. Okay. So Python and SimPy, okay, can be used. So SimPy, I'll just introduce what is SimPy. It's just a library in Python. Can be used for both of these applications. So what is the advantage? The advantage is that it's free. You can do whatever you want by writing models. Okay. And the most important advantage that I feel is that it's highly flexible. Okay. So if you use existing simulation tools, let's say web-based tools, then if you want to do something slightly different, they may not offer you the option. So with Python, it's essentially a programming language, so you can do pretty much anything that you want. Okay, you can model interesting scenarios, you can model interaction between nodes, you can model fault scenarios, and so on. You can use a large number of existing packages that are available in Python. For example, optimization, statistics, visualization, logging. These are all packages available in Python, which you can plug in and use in your simulation. The cons are, of course, it's like making your own simulation tool. Okay, so you are essentially making your own simulator, but it's not as difficult as you may think when you're using a ready-made tool called SimPy. It's a package. There is some learning curve, and essentially you're developing the models of the nodes yourself. But once you describe these nodes, then you can reuse them, right? So it's not necessarily more difficult than using any of the other simulators, but it's certainly more flexible. Okay. So to motivate this to motivate this, and before going into what is discrete event simulation and what is SimPy, before going into the details, let us see a demo session or a hands-on session. So that will serve as a motivation. Okay. So before this, are there any questions? Yeah, there's some disturbance. Somebody has commented. Is it fine now? Is the audio fine now? Sharad, can you confirm?
Yeah, it is fine. Can go ahead.
Thanks, Sharad. So let's see a hands-on session. So I want to simulate a temperature sensor node. Okay. And what do I want to do? I have this temperature sensor node, and let's take a very simple functionality for now. It just sends some temperature values periodically after some interval. Let's say after an interval of 5 seconds, it sends some temperature values. Now you may say, why not do it using a while loop, just a for loop in Python, right? Well, it's essentially the same, but now once you have this, you can do more complex things, like initially it is just sending something, then it enters an error state, then it does something, or there are two temperature sensors that are interacting with each other. Okay, so if you want to simulate such things, it is best to use a discrete event simulation framework like SimPy. So let's see, and I'm going to stick to the tools which I used in the previous session. So in previous session, so basically I want to try this temperature sensor, right? I actually want to generate values to a cloud platform. So what cloud platform should I use? So I can just use demo.thingsboard. Okay. .io. This was covered in the excellent session by Mr. Bhupendra Singh yesterday. So let me just use this. So let's create a cloud platform using this things board. Okay. And then I will simulate this temperature sensor on my PC. Okay. And it should appear on the dashboard. And then I can create multiple such sensors and so on. Okay. So let's so I've already created an account on this demo.thingsboard.io, and I want to create a dashboard. So I will simulate my temperature sensor node, and the readings will appear on that node. Okay, so let's create a device dash. I want to create essentially a dashboard. So let me register a device and then actually create it. Okay, so let me create a device, new device. Let's call it SimPy temperature sensor. Okay. Need to add a credential for this. So let me add a device called temp sensor 1. Okay. And we select some credentials, access token. So let's call it temp sensor 1. Okay, and that's it. So I have created this device. Okay, and I want to be able to visualize the data that comes to the sensor. Okay, so as was discussed in the hands-on session yesterday, you can use the curl command. Okay, so I would be using HTTP to communicate with this sensor. Okay, and one can use the curl command. So what is the access token? Access token is called temp sensor 1. Okay, so let me use the curl command. This is the format. So I've already created a file called sensor data. Okay, it's just like a Python dictionary. And this, I want to send this data, for example. Okay, temperature 39 and humidity 90. It's just a Python dictionary. It's a JSON string actually. It's a JSON file. So okay, I want to send this data. So what is the command? So this is the command curl. Okay, I want to post sensor data.json to, this is the URL, demo.thingsboard.io. So I'll make this public first. This has to be made public. Make device public. Okay. Yeah. So now it's there is a URL for it, and I can post my data for the sensor using a HTTP post request, and it will be associated with this device. Okay. So what is the access token? That access token has to be used here. So this is the URL, demo.thingsboard.io API v1, and then that's the name of the sensor that I have to use. So temp underscore sensor underscore 1. So that's my access token. So I'll try to use it. Okay. Yeah. So it was sent. So let's see if this data has appeared. So latest telemetry. Yeah. So it has appeared here. Okay. So so this is fine, but I want to create a dashboard. So let's create a quick thing for visualizing it. Let me add a dashboard.
So Neha, can you show where that sensor code was, the model of the sensor?
There is no sensor yet. I'm just creating the middleware.
Okay.
So the purpose of doing this is, let's see, again going by our philosophy, I want to simulate a temperature sensor. But what do I do with it? Once I simulate it, how do I show that it is working well? So I'll create a dummy middleware. Okay. So I'll not write any sophisticated middleware, but I'll just write a dashboard for it, so that my temperature sensor, when I simulate it, and when it sends the data, it will actually go to the cloud, and it will be shown in my web browser using that dashboard. Okay. So I am actually just creating a dashboard. I'm just saying that I have just registered a device. I'm saying that my device will be called SimPy temperature sensor 1, and I will create a dashboard for it, and then I will simulate my device, which will send data. When I send the data, it will appear on the cloud. So that's what I'm doing as a first step before actually
Okay.
writing a simulator.
Yeah. Okay.
So okay, so I have registered a device here. This is not actually creating any simulation for a device. Okay, it's just saying that my IoT system has this device that I want to register. It's not simulating anything, but I'm just associating it with a name and a token, access token. Okay. So you can sort of do some device management here, as in who should be able to see the data associated with device and so on. But essentially, I'm just making it a public, just a very simple device. And when I simulate it, the value should arrive, and I should be able to see them. Let's say on a time series chart. So let me create a widget for that. Let me create a dashboard. Go. One sec. Oh yeah, here. Okay, so here, since I have created this dashboard, so I will open this dashboard. Okay, right now it has nothing, so I'll add a widget. A widget is like a ready-made tool for showing certain kinds of data series. Okay, so I should know the kind of data which is coming from my temperature sensor. So I have decided that my temperature sensor should look like this. It should have temperature, this attribute, temperature, and an integer value, integer or a real value, and another attribute called humidity and this value. Okay, suppose I know this. So now I want to display this. So let me create a new widget, and I can select any of this type. Do I want a chart? Do I want a like a dashboard, sort of a gauge? So I just want a chart. Let's say a time series chart. Okay, and it will just show this. Let's say a bar chart. This makes sense. Okay, and what is the data source? So data source I will add. Okay, entities. Let me call it sensor one. Okay, and the keys will be okay. So create a new one. Temperature. Okay. Yeah, this is it. Yeah. So the key is temperature, label is temperature, and it will display it in blue color. That's all. Okay. So done. What happened? It didn't get saved. It didn't get saved. So I will associate it with this device, temperature sensor one. Okay. And temperature. Okay. So yeah, and let me add this. So this is started now. This is functioning. There is a dashboard functioning now, which is waiting for my device data. But right now I have no simulator data. Now I have the dashboard built, but I want to simulate my device. Okay, so let's try. So you remember this simple curl command. Okay, so what is this? This one command is essentially creating a simulation of my device, a very simple simulation where my device is just sending one message. That's it. What is the message it is sending? It is sending this message, temperature 39, humidity 90. Okay. So if I send the same message a bunch of times, it will appear on the dashboard. Okay. Let's say I send it thrice. So this is appearing on the dashboard. Let me see. Yeah, it has appeared. So only temperature is being logged. So I can create similarly another widget for showing the humidity also. So add equation 01 humidity. Okay. So now it is plotting temperature and humidity as a staggered plot. Both the values it's plotting. So you might say, why is this a simulator? This is not a simulator at all. Okay, I'm just testing the command. Right now, this is the format. And so I just want to know the format for sending. So what do I need to know? I need to know the URL of my middleware. Where is my middleware? So it could have been on the local host, but right now it's on the remote machine. So it's located at this URL. Okay. Then I need to know some access token to identify my device. So this is the access token, temperature sensor 1. Okay, this is my access token. Okay, and finally, I need to know what is the data that I'll be sending, which is in a JSON file. So now I'm ready with the messaging format. So let me make this now a simulator. So essentially, what do I want is to simulate the behavior of the device, or what should be the state of the device. Let's say right now its state is sending message, waiting for a response, or error state, or whatever, some state. And I need to be able to define how to send a message. Okay, send and receive. So post, let's say if I'm using HTTP, then it should be HTTP post, HTTP get. If I'm using MQTT protocol, then there'll be some other way of sending. But how does this simulated node send or receive messages to the middleware? Okay, so I have to define this. So for this, I got the format from curl. So I just a curl just a command for sending HTTP post or get requests. Okay, so I just tried it out using the curl command, but that's not my simulator. Right now, I want to do something more. So let me use Python and SimPy for writing my simulator. So here's a demo. Okay. So I want to make a simple temperature sensor node. This is just a text file. Just like you can edit it in any editor like Notepad or anything. It's just a Python file. Okay. Now, what I want is I want my sensor node to send the data periodically. I could have just built a while loop and done it using. So here's one way of doing it. I could just have a function that there's a while loop and it sends the value. Then there is a time dot sleep to wait for something, and that's in the while loop. So it sends periodically. But that's not a simulation again. It's just a Python code for sending. Now I'm building a simulator. Okay. So I'm using SimPy. Okay. And this is my sensor node. This is my simulation entity. Okay. So I'm simulating a node, and every sensor node has a unique access token. And what is this behavior? It sends the values periodically. So after 5 seconds, let's say, I can specify the interval. Okay. So let's say interval is 5 seconds. And this is just a variable. So while true, it will create some data. So let's say temperature keeps rising. So I can say temperature is 30 plus some count. So first will be 30, then 31, 32, and so on. And humidity is 90. Let's say. Okay. And then I send the data. So this whole curl command, I just put it inside a function. So the send data function just takes this value, whatever it is, okay, puts it in a JSON file, json.dump, and then it calls the curl command. Okay, so curl sensor data, then this is the same URL, And let me change this. So this was temp sensor 1. Okay. Now, ideally, you will not use this curl command. The proper way to do this is to use the requests library in Python. So you would have import requests. So this is a library in Python for sending HTTP messages. Okay, and curl is one application which does that. So essentially, there's no need to use curl here. I could have just used the HTTP request library, but since curl is simpler for this example, I'm using it. But it's not. I don't think it will result in the best performance. Okay, so if you want good performance, you should use the proper library. So if you're using MQTT, for example, you should use the appropriate library. So in this particular case, I'm just putting the command here. Okay, and now, so this function is just sending the data. It's putting it in the JSON file, and it is calling the curl command to send it. Okay, and now the sensor node, the behavior is there is a while loop. Okay, then I'm creating the data to send. I'm calling this send data function, this function, and then I'm just printing something. Let's say print time. So this is a SimPy thing. I will discuss what it is, and just printing the count and sending the data. Okay, and then there is this, which acts like a timer, time.sleep, but it is a simulated time. Okay, so you are simulating this time interval, after which it is woken up again. So sensor node is kind of woken up after every 5-second delay. Okay. So now in SimPy, this is the approach to create these sensor nodes. So this is just defining what should be the behavior. Now I create an environment in SimPy. Okay, so this is a SimPy class which sort of creates an environment. So to show a picture, I will create an environment. This object is called env, environment, and in which I can populate many sensors. Let's say sensor T1, T2, and so on. I can create many such sensors, okay, inside the simulation environment, that they can interact with each other if they want, and so on. So right now, I have to define what should be this temperature sensor, right? So I have defined it as a function, and I have created just one sensor. So I have created an environment, and I have populated it with just one sensor. So T1 is the name of the sensor, and I have created a process, okay, which is of this type, sensor node, and I am calling it. So I have to give it the right name. So I think it was temp sensor 1. And I want my simulation to run until 50 units of time. Okay. So let's run the simulation and see. So I will run it using the Python+3 command and then the name of the file. So this file is called demo tempsensor.py. Okay. So after every 5 seconds, it is printing this message, sending data temperature 30. So this message is printing in a loop, sending data, and it's running in a loop with 5-second delay between each iteration, and it will run until 50 units of time. Okay, so it will send us a total of 10 messages, and because we have a foot count in this, so temperature is incrementing slowly. So let's see if that is appearing in our dashboard. So it's actually the simulation is running on my computer, is sending this messages to the cloud platform located at demo.thingsport.io. So let's see if this is appearing. So it is appearing, you see, and you can see that the temperature is slightly increasing. I think this blue one is the temperature and green is humidity. So the green is staying constant at 90 and the blue one is increasing. So let me modify it, make it more clear. Let me say temperature is 10 plus count and humidity is 20 plus count. So both of them keep increasing. Okay, so let me simulate it now. So initially it is sending temperature 10, humidity 20. Then after 5 seconds, temperature 11, humidity 21, and so on. Okay. So let's see if it has appeared on the dashboard. Yes. So temperature 10 and this is 20 is about twice there, and it's appearing here in my dashboard. So notice that this is simulation running on my system, and it is actually sending data to the cloud platform. Okay. Now, why is it so attractive to use a simulation? So notice that there's not too many lines of code, right? This is essentially what is needed to describe what it should do and what value it should send. But it's so easy to create more sensors now. So suppose I just copy this and I create another sensor, okay, T2. So if I want to display its value separately, I will have to go back to this and create a new device, register a new device, create a different widget and so on. So suppose I don't want to do that, okay, so I mean, you can do it, but let me just create another sensor node, but it is sending the values which are going with the same name for now. I could make this temperature sensor too and create a different sensor, but this is another sensor node. Okay, essentially it will create two copies of this, but that's not interesting, right? I want to be able to see that there are two different sensors. So let me give it a name, okay, or let me give it an ID. So I know that which is the sensor that is sending the value. Okay, so the first one has ID is ID1 and the second has ID2. Okay, so what happens with this ID? This ID is also sent. So I'm sending data temperature, humidity, and also I'm sending ID. I'm sending the ID. Okay, so I'm also sending the ID, and these two have different IDs. So let's see if this will work. So of course I have to include ID in this plot. So let me add. It should also show the ID. Okay, so maybe I can add here temperature sensor 1 ID. Okay, so that is it. So let me now simulate this again. So what am I sending? I'm sending temperature, humidity, and also an ID. And I have created two sensors, temperature T1 and T2. So I should be able to see both of them sending different things. Okay, so let's see. Let me start the simulation. And let me also print this. So when I'm printing time, and I also print the ID, so that I know that which sensor is printing it. Okay, so there is a error. So let me put this into the manager. So this happens if you're using real-time simulation. So it is I'll go into this in detail in a while. So I made the interval 10 seconds. Okay, this is still going on. Okay. So what is happening is here the error is that the you are simulating is okay. after 10 seconds, something should happen, 10 seconds, something should happen, and so on. Okay. So what should happen in 10 seconds is the computer should simulate T1. So it takes some time to simulate T1. It should simulate T2. It takes some time to simulate T2. Then it should wait for the remaining time, and after 10 seconds, do the remaining things. But what is happening is this curl command is taking longer to respond. So it's actually taking more time than that 10 seconds. So that's where real-time simulation can be a problem. Okay. So actually your computer is taking more time to run the curl command. So it's ideally not advised to use this system.curl. You should actually use HTTP request library. Okay. But suppose we can simplify this. So we'll not use a real-time simulation. Okay. So we just simulate it as fast as possible. So the way to do that is to use just a normal simulation, not real-time simulation. That's it. So now it will run as fast as possible. It will not use real-time simulation. Okay. It will just do it as fast as possible. So let's see. So now it's running as fast as possible. So at time 0, the first temperature sensor sent this data. The second one sent this data. Then at time 10, the first one sent, the second one sent, and so on. So there are twice as many things. Okay, so there are 2 sensors. So it's very easy to simulate multiple sensors, first of all. And they're each sending this data. So let's see if this ID is appearing. The first one is by ID 1, then by ID 2, then so we are simulating 2 sensors. So here you can see this data appear. Okay, and the red is showing the ID. So the small bar is ID 1 and the big bar is ID 2. Although this is not a good way of visualizing the ID, we should have created 2 separate plots, one for temperature sensor T1 and one for T2. Okay. But yeah, so we can create this. So just by adding one line, I could create 2 sensors instead of 1. So that's the advantage. I describe the sensor here and I could create as many as I want. So let me just create another one, a third one. Okay. And this has ID 3 and a 4th sensor, which is ID 4, for example. So it's very easy to create multiple nodes if you write them this way. So by this time, the 4 temperature sensors have sent their packets, and then again after 10 minutes of time, and so on. So this is a simulated time. Okay, this is not matching the real time right now. It's not really 10 seconds. Okay, so if I wanted to match it or synchronize it with real time, I would have used this option. If I want to simulate as fast as possible, I'll just use this. Okay, this option. And so now it has sent. So let me see on the dashboard. So this has arrived, all the data has arrived. So at this point, I will take a small pause before going into what is SimPy and how it can be used and so on. So I hope that by this hands-on session, I was able to demonstrate that it is fairly easy to create multiple sensor nodes if you write them like this use this Python framework. Okay. Now, how do you model interaction between these sensors, and how do you create more complicated things like this sensor having different states or going into error state or so on? So we can see that. Before that, let me take a pause and see if there are any questions. So so there is a question from Dr. Mallikarjun BC. So his question is, why is this called simulation since we are doing this real time using ThinkSpeak or ThinkSboard. Okay, so I hope I understand your question correctly. I think you are asking why we are calling this simulation since we are using ThinkSboard, right?
Neha, your screen is not visible.
Yeah. Is it visible now?
Yeah.
Yeah, so we are calling this simulation because this thingsboard.io is just creating a cloud platform for us. Cloud platform. Somewhere, some destination where we are sending our data packets. But we have to simulate who sends the data, after what interval and so on, right? ThinkSboard cannot do that for us. We have to simulate all these temperature nodes. So these temperature nodes are sending data to the cloud platform, which is then being displayed. So what we did with thingsboard.io is just set up a dashboard to display the data which has been sent. But finally, we use Python to simulate these temperature sensor nodes. So the simulation of the endpoints was done using Python. So, is that, I hope that answers your question. Yeah, so this ThingsBoard will just allow me to create a dashboard. The actual device is being simulated on my computer, and the data is going to the ThingsBoard URL, and it's being displayed there. So I have simulated the nodes on my computer using Python. Are there any other questions? No, I think there are no other questions. So, okay, so your question was about real time. So there are two kinds of simulation. So the simulation can be as fast as possible, or it can be real time. But both are simulation. Okay. What does that mean? So suppose you are simulating a flight. You have a simulation model of you have a flight simulator. Like it's like a game, right? You simulate the flight, right? So that flight has to be real time simulation, because if you press a arrow key corresponding to turn left, the time to actually turn left for the aircraft should match the time that it actually takes for a real flight, so that you get realistic feedback, right? That's called a real time simulation. So where simulated 1 second actually corresponds to real 1 second, that's called a real time simulation. But if your simulated 1 second can correspond to any other time, can be as, let's say, 1 microsecond, or as fast as your computer requires, then it's called as fast as possible simulation. For example, if I am simulating weather simulation over the next 1 week to predict if there will be some storm, okay, this weather simulator will run the simulation on my computer, let's say in a few seconds, if it's fast enough. So the time it took to run the simulation for 1 week is not the same as actually this one. It's not taking 1 week, right, to run on my machine. So this is not a real-time simulation. So where the simulation time, the simulated time, and the real time, this can be greater than the real time, or this can be same, or this can be less than real time. So when it is equal to the real time, it's continuously kept in synchronization. That is called a real-time simulation. So I hope that that's clear. So the use of Python and SimPy is, first of all, it is free, it's open source. Okay, it's highly flexible. You can do things that you cannot do with a web-based tool, for example. Okay, so the learning curve is there. Okay, but I hope that the example served as a motivation for learning more about SimPy. So let me go on to SimPy. So what is SimPy? It's a Python library for discrete event simulation. So let me show this library. Okay. So if you just Google for SimPy, so you go to the documentation page. So this is the documentation for SimPy. It's a discrete event simulation package, or it's a library for Python. And interestingly, there is a SimPy in 10 minutes. It's a guide for how to install SimPy. It just one pip install SimPy will allow you to install the SimPy library on Python. Okay, and there are other ways to install it, but this is the simplest way. Pip install SimPy. Okay, then there are examples, very simple examples on what is SimPy and how to use it. So SimPy is a simulation framework. So basically there are these examples, very simple examples in this guide, okay, which you can go through. So coming back to this, it's useful, it's elegant, and it allows us to simulate lots of things. So basically it's a discrete event simulation. So what is meant by discrete event simulation? So sometimes you may want to model things which are continuous. So where the state of the system evolves continuously with time. For example, you're modeling the temperature of a tank or your level of a tank, for example. So that across time, the level of the tank may rise or fall or something, and that's continuous. Okay. You may want to simulate such a thing. Or you may want to simulate something where the state changes at discrete time instants. This is called events. So let's take an example of a same tank, but let's say you're modeling when the tank valve is on or tank valve is off. The input of the tank is on or off. Now this, okay, it can turn on suddenly or turn off suddenly, right? It's not continuous. Another example is, let's say if you're modeling an airport, okay, and flights arrive and flights depart from the airport. So the arrivals and the departures are discrete events. They don't happen continuously. So let's say at time 9:30 a flight arrived, or at 10 the flight departed or something. This could be the state of the system. Let's take for example a queue. There's a queue of people waiting at a restaurant, okay, and some people arrive and some people leave, and this is showing the number of people in the system. So it could increase or rise, okay, but this happens at discrete time instants. So such simulations are called discrete event simulations for modeling things that have a discrete set of events. So Python, if you want to simulate such things, then the library in Python is SimPy. For continuous simulators, there are lots of other frameworks, depending on what is it that you're modeling. So if you're modeling weather systems, or if you're modeling fluid simulations, there are other sorts of simulators for that. Or if you're modeling differential equations or so on. So SimPy is for things where there are discrete events. So how does SimPy work? So the basic idea is that you just have a queue, you just have a list, okay, that stores what should happen at what timestamp, and there is a sorted list maintained by timestamp. So suppose I say that at time point 2, a customer should arrive. So I say that event is listed in this queue. Okay. So there is a table maintained which contains the timestamp and what event should happen at that timestamp. And then how does the simulation proceed? You just start executing it from the top, from the lowest timestamp. So at time point 2, so there is a time variable called t. Okay. And initially t is 0. Then update t to the lowest variable. So t is 0.2. And see what are the events at that time. So event E1 is to be executed. So what does that mean? For event E1, whatever it is, let's say a customer arrives. So customer arrives, so the total number of customers is incremented. And let's say it schedules another event. So let's say after 10 units of time, that customer should leave. So at 10.2, another event is scheduled, that is the customer should leave. So 10.2 should be inserted here. At 10.2, the customer should leave. So this is executed in order, one by one. And one event can change the state of the system, and an event can cause other events to be inserted in the queue. So this is called discrete event simulation, and that's what is used in SimPy. Okay, so essentially we model the behavior of the system using these, like just like a function. Okay, and let's say a sensor node, a temperature sensor node, we model it as a function which becomes a process in SimPy, and that corresponds to when we start this, it can trigger an event and it can insert it in
Neha, can you share your screen again?
Okay, it is not visible. Okay. Is it visible, Sharad?
Yeah, now it is visible.
Yeah. So it's basically the nodes that we want to model can be modeled as a function in Python, and they become a process in Python. So process is something which is existing concurrently with other processes. So for example, the temperature sensor node, when we create it, it's operating concurrently with other sensor nodes. Okay, they are all operating concurrently. So essentially, we want to model concurrency, and we want to model time delays. So things happening simultaneously, and things happening at a certain time. Okay, and these things interacting with each other. So we want to model such things, and therefore we use this SimPy simulation framework. So some useful things that SimPy allows you to model are time delays. Like suppose a sensor is do something, then send a value, then wait for 5 seconds, then send some other value, wait for 10 seconds, then go into error state, and come back after error state after some time or something. You want to model some state machine like this. So you can do such things using SimPy. You can also model shared resources. For example, here is a sensor and here is another sensor, and they are both waiting on some shared resource, let's say in the gateway. So let's say gateway, if it is occupied, then it will not allow this sensor to send its value. So you can model shared resources. Okay. You can also model interactions between these two sensor nodes. Okay, you can model these things. And you can do real-time simulation. So in the example, I first started with the real-time simulation, and then there was a delay problem. So we switched to normal simulation. So you can do normal simulation or you can do real-time simulation. In real-time simulation, let's say if you have 1 second, okay, and let's say you're simulating 100 devices, and actual time each device takes to simulate on your computer, let's say that means to execute the Python code. It's very small, right? It's let's say it's some microseconds, let's say 1 microsecond. So this 100 devices, actual time to compute the state after 100 devices are simulated will be 100 times 1 microsecond. Okay, so that's 100 microseconds. So the remaining time the computer just waits, does nothing, it's idle. And after 1 second, again you simulate the behavior of the remaining. So this is kind of to keep it in sync with the, that is the time specified. Okay, so it's actually real time. You say that the sensor should operate and it should wake up after 1 second. So to keep it actually 1 second, you do nothing. But if it's an actual simulation, not real time, then whatever time the computer takes, at this point you will update the time variable and say t is now 1 second. Then do remaining computation, then say t is 2 seconds, and so on. So you'll just update this time variable as soon as possible. In real-time simulation, you will update the time variable only when actually 1 second has elapsed on your system. In reality, when 1 second has elapsed, will you update the time variable. So in SimPy, you can you both do as fast as possible simulation and real-time simulation. So this was I will share the code that is used for this. So I'll share this code with you. So you will just need to install SimPy library, and then you can do various things like create many sensor nodes, have them interact with each other, and so on. So this is just the Python code. So now I think there's time for questions. So I'll stop sharing my screen. Okay. Before that, let me just conclude. So essentially what was covered in this session was an overview of utility of simulation in IoT systems and some specific applications. So what do you need if you want to simulate IoT endpoints? What are some common tools for doing this? And what do you need if you want to simulate digital twins? And in hands-on session, we saw how to use Python and SimPy for creating some simple simulation models of sensor nodes. And a quick introduction to SimPy, though there's not enough time to explain how SimPy works, but I have pointed out a link to see how to use SimPy. So essentially, Python is a very open source way of doing this. You don't have to buy any simulation tool. You can use existing HTTP libraries to simulate your sensor nodes. So with this, I'll end this and take up questions if there are any.
So there is one question, Neha. How is it different from NS2 or NS3?
So again, like described in the overview, NS2 or NS3 are tools for simulating networks. So they are network simulators. They will be useful if you want to simulate aspects of the network layer, not of the endpoint layer. Okay. So this particular application that I discussed is when you want to simulate complex interactions between these nodes. Let's say like a temperature sensor having different states of operation and interacting with other sensors or interacting with an environment, okay, and visualizing that and so on. So NS2, NS3 are network simulators, whereas what we are talking about is how would you simulate the endpoint layer. Yeah.
Okay. Any other question?
Yeah, so I will. So there's a question about suggesting any references for digital twins. So I will add some references at the end of the slides when I share them, and Sharad will circulate the slides with you all. So there are some books and some papers for digital twins, like an overview. So there is a nice IEEE paper that is an overview of what is a digital twin and so on. I can share that with you. Hey Sharad, you are. I think your screen is frozen, Sharad. Yeah. So thank you everyone, and I hope you find this session useful. And if you have any questions, then please you can please write to me. My email address will be there on the slides. snehak@iitgoa.ec.in. So if you have any other questions about SimPy or Python or using these simulation tools, then you can write to me. I'll be happy to answer any questions. Yeah. So thank you everyone.
Ma'am, are you there?
Yeah.
Myself, Pranav Tandre, I am having a query.
Yes.
Ma'am, thanks for the informative session. I've learned a lot. I just wanted to ask one question. The tool that you have shown in which you are uploading the data over the internet, can I can I back up that data for the future reference in the form of a CSV file?
If you are talking about doing that in the cloud, okay.
Yeah.
So in the tutorial that I showed in the hands-on session, we just use a ready-made cloud platform, that is Thingsboard.
Yeah.
Okay. So if your question is, can we do a backup of data on Thingsboard? Then I think there should be a way to do it. I am not an expert on Thingsboard. I just used some endpoint. The focus was on simulating the device layer. So I think this query, I mean, I can find out and tell you, or I think it's better if you direct it to Mr. Bhupendra Singh, because I think he will have good experience with that.
So on Thingsboard platform, you will have the option to download the data that is there. Okay. So you can download, I think, as a CSV file. Yes.
Okay, sir. Thank you, ma'am. Thank you, sir.
Thank you.
So any more questions? Okay. So if no more questions, then on behalf of myself, IIT Goa, and all the participants here, I would like to thank Dr. Neha for an interesting discussion on how to simulate IoT endpoints. And I'm sure you can, if you are not having access to a board, you can simulate these endpoints by writing Python code and connecting to a platform where you can create a dashboard and things like that. So with this, we will end this session. Yes, I will share this video because this was a hands-on video. I'll share it tonight, and we'll move to session 4. The link is there in your email, and tomorrow you have your exam at 2:30. At 2:30? No, sorry, at 12 o'clock. The second session would be your examination tomorrow. So thank you, everyone. Let's move to session 4. The link is there in your email.
Yeah, thanks everyone.
Thanks, Neha.
Thanks.